cambiar vidas,
change lives,
change organizations,
change
दुनिया में
organizations,
बदलाव.
Change the world.
My pleasure to be here. I'd like to talk about energy efficiency in the context of cities, but I want to take it from a broader point of view of what I think those of us who are working in the energy area are really trying to accomplish in sort of the bigger picture. I start with an apology, is that most of the data I'll show you is US data, it's not Taiwanese data. I just don't have the access to some of that. And I'll show you some data for background. But what I think we want to do in the energy system is really try to move towards what I'll call a sustainable energy system that has a number of components. One, international security. An energy system that's predictable, reliable, compatible with international relations, both for an individual nation and the world. But those who are watching what's happened in Japan now understand that one dimension of security can be associated with what happens if your energy supply, your nuclear plants, in their case, go down. If you see some of the threats in the Middle East, you see the security issues on the supply side in oil. So the first, got to think about these issues of security. Second, energy is fundamental to the economy. And so how do you develop an energy system that gives you the energy efficiency so it's affordable, abundant, competitive, profitable enough so the industries want to be continuing to invest in that. And so is compatible with your national economic issues. And finally, environmentally protective. For me, the most important issue was global climate change. Although in the United States, we're now to a point where 60% of the population questions whether global climate change science is actually real. And all of the Republicans in Congress have decided that the science must be a fraud. Even though that is true, fundamentally, we have a problem of greenhouse gas accumulations. And those are mostly coming from the energy system. Those primarily energy systems, secondarily from the agricultural system. But there's other environmental issues besides climate. If you go back to China and you go through the cities like Beijing, you understand the quality of the air is made significantly worse by their energy system. So this is essentially what you want, and I sort of talk about this as the energy policy triangle, where we really look at the economy, environmental protection, and energy security as sort of the fundamental issues. So when I'm talking about energy efficiency, I'm going to be talking about energy efficiency really for all of those reasons. And for an individual nation, you have to be taking into account all of those simultaneously. If we look at the system of how energy is generated in the world, there's a lot of discussion about the great significance and the great growth of the renewables, wind and solar, so forth, geothermal. I want to point out solar in the worldwide has grown from this to this. So it's often described as the most rapid growth rate, but in percentage terms it probably is because it's moved from that to that. Wind has moved from that to this. Geothermal that what really dominates the system is really the fossil fuels. No matter what we think about the renewables now, the fact is that the energy system is dominated by petroleum, natural gas, and coal. Nuclear and hydro are the only other ones that really are in significant quantities. So then if we're trying to deal with global climate change or other environmental issues, we can think about how we expand these up, but we also can think about shrinking these various elements. Because quantitatively, if you can get 10 or 20% shrinkage in the use of energy, the quantitative impact is really much greater than you can get over the next probably 20 years from these renewable supplies. Now, does that mean I'm against renewable supplies for the other nations? Of course not. But we've got to pay attention to scale and the rate of adjustment of complex systems. And the energy system is one of those fundamental complex systems that's massive in scale. So that as we think about changing things, paying attention to scale is really important. So if we're talking about what we can do in the next 50 years, probably this is what we can do in the next 50 years. If we're talking about the next 20 years, probably how we can reduce the use of energy is probably the most dominant thing. That's US, that's world data. US data doesn't look much different. We still have oil, natural gas, and coal as being the dominant, a little bit larger proportion of nuclear, a little larger proportion of renewables, but the same comments hold pretty much for the US as for the world. So the first lesson is, I believe that a country like Taiwan, thinking about what they can be doing, of course have to pay attention to the supplies, but they probably want to talk about how they use energy and the efficiency. Now, if you look at US, how we release carbon dioxide, we can think of the direct use of release of carbon dioxide here from petroleum, from natural gas. But this yellow is the indirect use of carbon dioxide through electricity. We can look at all of the carbon dioxide released from generating electricity in the United States and say, oh, that's the electric sector. But of course, you wouldn't generate electricity if you didn't want to use it for your industry and for your households, for your commercial sectors. And so if you take all of that carbon dioxide that's released in the United States for generating electricity, and you distribute it to those various sectors in proportion to the amount of electricity that's released, then you get these yellow sections. And what this says is, if you're thinking about energy efficiency in the United States, and I believe this is the case in Taiwan as well, there's two things you've got to focus on. One, the use of electricity in residential and commercial sectors as well as the industrial sectors. And separately, how you manage your transportation system. Now there's a session, I'm not going to talk much about transportation because you have a session this afternoon that are focusing on transportation. And the issues in transportation actually are quite different from the issues for residential and commercial. As you're structuring cities, of course, you're paying attention to both the buildings and the transportation systems in those. So I indicated that most of this is use of electricity in these sectors are basically what happens in buildings. And so much of my focus is going to be on buildings. So if we ask in US, how we use energy in buildings. And I don't know whether the data in Taiwan are similar or other Asian countries are similar, but the biggest elements, if you look at space heating, space cooling, and lighting and ventilation, that's half the use of energy, more than half of the use of energy. So this has to do with the shell of the building. The other half has to do with what people do in buildings. So you can make the shell of the building more efficient, the heating system's more efficient, but we've got to then also pay attention to the sort of things that people do in those buildings. They heat water for bathing. You have cooking, you have cleaning, refrigeration, electronics, computers. So that I think is important when we think about the buildings and the cities that have those buildings, that we pay attention to both these things that have to do with the system of the buildings themselves, the heating, cooling, lighting, and ventilation, as well as then all of the things you do in the buildings. So if you think about sort of a rule of thumb, buildings in their operations maybe release about 1/5, 20% of the carbon dioxide in the United States. The things people do in the buildings are another 20%, so 40%, and then the rest is transportation and industries. So then if we're trying to now promote energy efficiency to make cities more sustainable, we want to have very different actions for these 4 classes of carbon dioxide emissions. Some of those things we can manage through information technologies and smarter systems. Some of them we have to pay attention to what the human behavior patterns are. Some of them we have to deal with actual large infrastructure investments. And so one of the complicated things about energy efficiency is it's not one thing. It's hundreds and hundreds of different types of activities people pay attention to. The other thing that's important when we're thinking about energy efficiency in buildings is the dominance of the existing building stock, unless you're in China. In mainland China, the new cities are building so rapidly that you can really pay attention to creation of new cities and new buildings. In the rest of the world, United States, Europe, you have the existing stock of buildings really dominates the fleet. In the United States, historically, residential construction about 1 to 1.5% of the stock is replaced each year. So that means the time constant of adjustment is terribly long. You can have maybe a 40 or 50-year time constant of adjustment. Now, right now, while we have such a bad economic situation, we're building at a much lower rate, so the time constant of adjustment would be even larger. Commercial construction per decade, we may change 15 to 20% of the floor space. What that means is that if we really want to go for energy efficiency, we have to focus not just on the new construction, but on the retrofits. And as the point was made earlier today, retrofits are a lot more complicated than energy efficiency in new buildings, because the retrofits both means redesigning existing buildings. Very difficult to go in and do the same thing for all of them because you have to start with what's there. And you have to deal with the motivational issues. Why does the building owner or the building manager decide that they want to do energy efficiency? And it was pointed out earlier today that in buildings, there's a lot of different decision makers. And the incentives for the building owner may be very different than the incentives for the person who's managing the building or the tenants in the building. So important thing to deal with in the energy efficiency in buildings is really come to grips with the issues of retrofit. If you're dealing with that half of the energy efficiency that is the shell of the buildings themselves. So why, you may say, you know, if energy efficiency, really there's a lot of economically attractive options, and we heard about some of those this morning, that you can go in and economically, attractively do many things. But frankly, there's a lot of economic and behavioral barriers that get in the way of doing all of those things that you consider that make sense. For example, I talk about the principal agent problem. Here you have different incentives between the owners and between the people who may make the capital decision and those people that use it. For example, if you have a building structure so that the tenant is rental, so the tenant pays the electricity bill, but the owner does the capital improvements, and there's imperfect information, as there tends to be in at least in residential buildings and to a large extent in commercial buildings, then there's an incentive for the building owner to not invest in energy efficiency, realizing the tenant pays the cost of the use of energy. Alternatively, you can have a system where the building owner pays all the utility bills and then makes a capital investment. Well, then they have lots of incentive to have the capital investment improving things, but then the people who are the tenants have no incentive to use the building efficiently. And you see this all over where people on a hot day, on some days will have very intensely cold air conditioning because they're not paying for the air conditioning. And to make some parts of the room comfortable, they open the windows. Well, it's very inefficient use of it, but as long as the building, the cost of the utilities are paid by somebody else, there's wrong incentives. So is this theoretical problem a real problem? We have some data in California to look at the difference between owner-occupied and rental buildings, about the degree to which the market penetration of insulated walls, insulated attics, all of these energy efficiency options. It turns out, take insulated attic in an owner-occupied building in California. If it's owner-occupied, over 80% has insulated attics. If it's rented, under 40% has insulated attics. Insulated walls, it's about 40% differential between those two. Even things that the renters can change themselves, compact fluorescent lights and low flow shower heads. They can change it themselves. You know, you can pay for change all the lights over to compact fluorescence, and you can pay for themselves in a couple of years. But a lot of the rental buildings, people stay in 1 year at a time, so people can do a good favor to the next person who's living there. But even that, you still see this incentive problem of renting versus owner-occupied. So first is that the structure of ownership and who pays what empirically does make a difference. In the United States, we can look at data from the Residential Energy Consumption Survey, see the same pattern of owner-occupied versus rental, of a difference between the energy efficiency in the building. So that's a barrier that gets into the way, this economic incentive problem. There's a set of institutional problems. The construction industry, at least in the United States, and I know in Europe, but I don't know whether it's true in Taiwan, is a very fragmented industry. very difficult to get complete integration between the architect, the contractor that's building it, the many different different crafts that are associated with developing a building. So you end up having the ideas that come from the architect don't always quite make it to the final decision. But even if they did, what we need, you need at the architect and the first decision making, you have to make decisions for energy efficiency. Well, to make those decisions, they have to know what things actually lead to energy efficiency and what don't. So they need good mathematical modeling tools. And as it turns out that the best mathematical modeling tools we have right now are actually grossly inaccurate. So for those who are into information modeling, there's really opportunities for much better building. I give you some data for our LEED building. These are buildings that are meant to be green buildings, really as environmentally conscious as possible. And if we look at energy use intensity, that is how many BTUs per square foot, and we look at what their design was versus the actual measured energy per square foot of the building for these green buildings. There's a limited set that was sampled because most of the green buildings, those LEED certified buildings, are certified based upon the stated plans of construction. They are not certified based upon the reality. In fact, the reality is generally never measured or reported to anybody. So, but for those that, for a sample of those that are, you'll see things like this is going to have, say, it measures 1,000 BTUs per square foot. This is measured to have 60, was designed to have 60, and in fact was very efficient. It only had something like less than 30. And that had more than 100, even though it was designed for less than 50. Similarly, those that have advertised to be very, very energy efficient, say in the order of, say, 30,000 BTUs per square foot, tend to end up having much more energy use than they were designed to use. Well, why is this? Well, there is a correlation. You know, they are correlated, but there's a wide scattering. And it seems to me that the reason is because the mathematical modeling tools that we have are just grossly inaccurate. We give you just a small example from the building that I'm in, the Y2E2 building, very environmentally conscious. We have night flushes where at night we cool off the building by opening up vents and hot air rises, cold air comes in, cools off the building. We use the best models that are used for examining energy in buildings, and these say that the building should cool off in less than an hour. It should cool off. In fact, when we do it, it takes 8 hours to cool off. Well, if we have, in terms of these dynamics, an 8-to-1 difference in how long they accomplish, and we know that energy efficiency in buildings is a dynamic process, it's not a static process, because it's a process of heat flow, then we recognize that the best of the modeling tools aren't doing well. So that's a problem. That's a barrier. There's a set of behavioral problems that are barriers. very poor information that most people have about the energy use. Let me just ask here. Most of you have televisions. Do you know how much energy they use? How many know how much energy is used by their television? Just raise your hands, just if you do. Oh, no. Raise your hand if you don't know. Okay, good, good, good. So you are listening. I have a particular example that irritates me, and I'll just give you, this is a small energy use, but it is, I get cable television. And there's a set-top box that can record the programs so I can see it at a different time. And I measure how much electricity it uses. When it's turned on, it uses 38 watts. That's not bad, not a lot of that much electricity. Then you turn it off. It uses 38 watts when it's turned off. And you say, no, well, why is this turned off? It looks like it's off. The tiny little LEDs on the front have gone off, but those use almost no electricity. And you go and you listen and you hear humming. And you notice it's warm. Well, why is this humming? It's warm because it has a hard drive in it. And it never is turned off. Now, every computer manufacturer in the world has figured out power management and hard drives. But why hasn't Motorola, that makes this desktop box, why haven't they figured out how to turn a hard drive off? And well, the first answer was, well, they need to get information from the network for what the programs are going to be. That makes no sense at all, because that's only a very little amount of information, and you put that in non-volatile memory. And we all have non-volatile memory is cheap. I've got, this costs almost nothing, this non-volatile memory, so you can put that in. What you need the hard drive for is when you record the programs. But if you're not scheduled to record a program for the next week, you don't need the hard drive on waiting for the next week. But Comcast, which is the cable company, they pay for the cost of the box and the repairs for it when the hard drive goes off. And turning hard drives on and off are more likely to have it need repairs or be replaced. And I pay for the electricity. So they probably save themselves $10 or $20 on each one of the boxes. And as a result, I pay $100 more per year for the things because they don't want to spend the money on it. So those are sort of a barrier. There's an information related to barriers and an incentive. In a lot of these appliances that we have in the buildings, nobody has a good measure of the electricity use, so there's not much incentive for the manufacturers to really manage energy efficiency. Let me just jump ahead to talk about how do you overcome these challenges, because I know I'm running out of time. First, it's just not one problem, so that you've got to be thinking of matching solutions to this. One of the things that I'm very excited about is smart meters and the type of feedback. We talked about this morning. But right now, the way smart meters work in the United States, for motivating energy use, we have some data that they're completely useless. They are useful for not having to hire meter readers. And they're useless for the utilities. They're useless for the utilities to know when there's an outage so that they can deal with it. But for motivating people, they're basically useless. I'll give you this experiment that we did earlier. Was mentioned Google. Well, we did this with Google, where we wanted to do just an experiment on how much feedback through smart meters really made a difference for consumers' choice of use of electricity. So Google recruited employees, they volunteered. We split up this into a control group and experimental group, random distribution into the two groups for the people around the United States and Google. They all had smart meters that gave whole house data. Now the smart meters we have around are only whole house data. It's not explicit appliances. Whole house data with the possibility of real-time feedback with a 10-minute time intervals. The difference between the control and experimental group is that the experimental group could use Google Power Meter to see their electricity use on a real-time basis. The control group had no access to that. In the first month, the experimental group reduced their use of electricity about 5.5% below the control group. Within the first month, 5.5%. Sounded very encouraging. But by the end of 4 months, there was no statistical difference between the two. So then it was announced that the experiment was over. That, of course, was a lie, because the experiment wasn't over. It just told people it was over. And being over, we said then everybody can use the Google Power Meter to start observing their electricity use. So the only thing that's changed is now the control group has access to the Google Power Meter. The experimental group still had access to it. And in the first month, the control group reduced their electricity use 5.5% relative to the experimental group. And at the end of 4 months, though, there was no statistical difference. So what my interpretation is, and people could put different interpretations on this, is that those whole house just electricity consumption data get people's attention for a short time, and they do something. But by the end of a couple of months, nobody pays any attention anymore. And if they don't pay any attention, they don't act on it. Now, does that mean, remember I started saying that I think smart meters have wonderful potential. What could you do with them? Well, first, you've got to take either the smart meter and disaggregate the signal using algorithms to disaggregate the signal to appliances and turn that data into real information that people can use, that are actionable. For example, you can see an appliance sometimes give you an alert that says, your refrigerator is using more electricity than usual. You should clean the coils on it. Or it could say, we notice how much electricity your refrigerator is using, and we know how much it costs to buy a new refrigerator. You could save, in the electricity saving, you could pay for a new refrigerator in, I don't know how many years. It can tell you how much. And it could say, and here's the places where you can buy them, and here's the different models. That becomes information, not just data. And it could also say something like, if you say, I want to change the set point of my thermostat 2 degrees, and it said, this is how much it'll cost you per month. Right now, the smart meters we have in the United States and the feedback, I claim, are now useless for changing motivations. But they don't have to be. And here's a technologies that can be developed, but they're going to have to be done with a sophisticated notion of how people behave. What actually makes a difference? So I'm going to end at this point because I see a red sign there that I'm refusing to read that says stop. And just suggest that there are other types of motivations, as we can see from this little cartoon, which I'll read. It's a salesman selling a car. It says it runs on his conventional gasoline-powered engine. until it senses guilt, at which point it switches over to battery power. Well, there's a lot of behavioral issues that we can talk about, but I've run out of time, so I'll stop now. Thanks.
On the metering, you were referring to the American experience, I suppose.
Yes, I'm for what we see in the United States right now, and I was explicit about that.
Right. Now, is there foreign country experience on meters that is informative? Do you know about?
I am not aware of any that's done any better than this.
My question is on this motivation that dies out over time. How much of that is because the household cost of energy is still small? I mean, it's kind of small compared to other household costs.
That's one of the points I skipped over. If we look at total expenditure in the residential sector on all energy, it's only 2.2% of the total disposable personal income for the households. It's, as Bill suggests, it's a small fraction of your income. It's not just a small fraction of your income. It's hundreds of decisions you've got to make, all which collectively add up to a small fraction of your income. And none of them are ones in which you have good information. So poor information, at best you may have data but not linked to information. Many choices, small fraction of your income. It's what amounts to what we call low salience. People have low salience for these sort of choices. So to get to motivation, you've got to do something to recognize it can't be a lot of work to do all of these energy efficiency actions, or people won't do it because it's too small a fraction of their income. Actually, let me just tell a story the way I illustrate it. Most of we get an electricity bill, I don't know, you get it once a month or whatever. But I imagine going into the local supermarket where I want to buy some meats, and there's filet mignon, and there's flank steak, and there's chuck steak, and there's porterhouse, and there's hamburger. But there's no price tag on anything. In fact, I've never seen a price tag ever before in the market. You got to imagine this situation. And so you buy a lot of filet mignons, and you go check out, and they check out. So apparently there is a price tag, but they don't tell you anything. But at the end of the month, you get a bill that says groceries, $400. Now, how smart a shopper would you be for meat? How different is that from how we buy electricity? In my mind, it's exactly the same. You could go back on the web and infer what porterhouse is versus hamburger and cost. But most people won't because it's too small a fraction of their income. I think it's really parallel. So I think in grocery shopping, though, people actually pay attention to what they buy, even though it's not a much larger fraction of the income. So it's some combination of actually seeing the consequences of your actions that causes people to actually make differences in what would otherwise be low salience, but they don't in electricity because they don't have the good information. Let me draw you a graph here. Think of the horizontal axis as years, vertical axis electricity use per capita, and in the it goes started in 1976 and goes up to currently, and it says that U.S. for the United States has gone up 50% in that time, and California's has stayed flat. That's what you've described as the Rosenfeld curve. So now you ask why, and this is where I disagree with you, the interpretations. You can start decomposing that difference into what's happening in various sectors. In the commercial sector, for example, the entire difference between California and the United States is accounted for by the fact that there's less commercial square footage of buildings per capita than there is in the rest of the United States. We use the same amount of electricity per square foot of commercial space as the rest of the United States does. We just have less commercial square foot. So that accounts for all of it in the commercial sector. Because at the beginning we had in '76 had the same amount of commercial square footage of land of commercial square footage as is the United States. But the high price of land in California and the high price of real estate has led to less commercial development in California per person than the rest of the United States. So that's why that diverged. We can go through every single sector. In the industrial sector, most of the difference is because we tend to have a more information technologies and our industry are not the heavy production, but it's the high tech that's a lot less energy efficiency. In the residential sector, you can break it down to one, we have more people per residential building than the average of the United States. And electricity use doesn't scale with the number of buildings. It's not proportional to the number of people in that. So if you have more people per building, then the electricity use per person is lower. So we have that. We have the climate difference. As over time we had more and more air conditioning being put in, United States, California having a temperate climate used less of that. We have more self-generation. So you add up all of those things together and you see of that whole difference, 80% of it can be accounted for by those demographics, industry structure, climate issues. 20% of the difference can be accounted for by the policies in California. So I agree with you that the California policies probably reduced our use of electricity by 10% from what it would have been otherwise. The Rosenfeld curve would have caused you to conclude there was a 50% difference, but it's really only a 10%. I have those as all slides. You'll have to imagine what the slides would have looked like. But that's been done by a decomposition method and then by econometric methods that do. Anand Sudushan is the person's name that did that work. The policies in California have probably reduced the electricity use per capita by about 10%, 10 to 15% from what it would have been the rest of. The rest happened naturally. The rest of that difference happened naturally because of demographics, climate difference, and industry structure, and the high price of land in California, none of which are energy policies.
By 2020, they're going to increase the renewable to 20% and improve efficiency by 20% and reduce carbon dioxide 20%. And then they discover on the renewable side, no problem. But as green as the Europeans are, their 20% target for efficiency is going to be only 9%.
Right.
And as a matter of fact, compared to the United States, they're a lot worse off. So you're saying that the United States are not really doing that well either.
No, here's what I am saying, because I think I left the wrong impression. First, if you look at the California policies, they actually have not been very severe policies. There have been building codes that apply to the brand new buildings, but the brand new buildings are a very small fraction of the buildings. And those building codes have been designed for things that are calculated to be cost effective, taking into no account externalities. So they've actually been, while they look strong, they've been relatively mild. We have with the electric utilities, we have over this time a decoupling between revenues that the utilities get and their sales of electricity. So we've eliminated the incentive for the utilities to sell more electricity, but it's only in the last 4 or 5 years that we actually have positive incentives for the utilities to reduce electricity use. So that's been a program that have just recently started up. In the residential area, we've until recently have had no programs on appliances.
Incentive just
What?
Incentive just recently, the past
3 or 4 years.
It's been
It
going
was
on for 30 years, you know.
The incentives through the utilities that started a long time ago was getting rid of the decoupling. That is,
Yes.
so now you can't get more profit by selling more. That's been going on a long time. So you've eliminated the incentive for utilities to sell more, but the utilities have not been really effective in being able to cause people to be more inefficient. So we've gotten rid of that. That's been good. But the incentives for the utilities to co-invest with their companies have been very mild up until the thing when Diane Grunick was a commissioner of the California Public Utilities Commission. She took the lead as putting in the strong incentives we have now for the utilities. I think it was about 4 years ago. So those are for retrofits. So those are really just ramping up now. So what my interpretation is that if you want to reduce electricity use the way you see in California, you actually have to take stronger actions than California has. You've got to, Europeans have, as they've gone through it, have not, in my mind, developed very strong incentives for the existing homes building. They have incentives for the new stock of houses, but that again is dominated by the existing homes.
They do now.
They do now, but they have not. So we'll see what they accomplish. But the point is, if you look at California, I don't take the lesson that you can't do anything. I take the lesson you got to do a lot more than California's done to get that outcome.
My last question. If those that has gone before really work just very marginally, then what should we do in the future?
Well, we've sort of run out of time. Those are the last slides. I think that what we have to do, we still should keep these building standards because those are important. I think those feedback devices will be important, but we've got to create real information which will be actionable that'll motivate things. We need some real-time pricing in electricity so that we create a little bit better, we have better incentives there. We need a lot of appliance efficiency standards. You know, my example of Comcast, I think that's just going in with efficiency standards can make a lot of difference in things like that where we have poor information. And finally, we need a group of behavioral interventions. We have things like the O-Power has inserts in electric bills which just compare you with the neighbors, and we see that gives to about 2% reduction in electricity use. Just if you get a bill that compares your use to your neighbors, on average, you will reduce your electricity use by about 2%. We now, O-Power has a Facebook app, so you can create these competitions with your neighbors. That's going to be part of it. I believe that there's going to be other behavioral interventions that we're going to end up having, but until people have good information about this, so they make buying electricity equivalent of information to grocery shopping, where people do pay, I don't think we're going to fix the problem. So we've got to really pay attention to those information and behavioral opportunities and linked it with the regulatory interventions.
About those incentives, Taiwan tried it this past year for only 3 months. And actually, ITRI was the institution that actually implemented it. In those 3 months, the grade 1 and grade 2, those are the top efficiency, top efficiency air conditioners. Their market penetration in those 3 months increased 90%.
Yeah.
So it works.
Right. Well, what we're seeing is that Energy Star, it actually makes a lot of difference. I view that as a behavioral incentive when we do Energy Star. If you have it, you could do it as a regulation, regulate against the inefficient ones, or you can have pulls by Energy Star programs which encourages you to buy the more efficient. That's part of the behavioral and information incentives I have.
Cambiar vidas,
Change lives.
change organizations,
change
दुनिया में बदलाव.
Change the world.